Hello, I'm Yanqiao from Chinese Academy of Sciences. It's my pleasure to introduce our recent work on structure-aware hard-cognitive mining for heterogeneous graph contrastive learning. Many real-world complex interactive objects can be represented in the form of heterogeneous graphs, where nodes and edges can have multiple types. As a de facto model for analyzing graph structure data, graph neural networks require a relatively large amount of labeled data for proper training. To alleviate the label scarcity problem, we propose to leverage graph contrastive learning, which learns representations by distinguishing semantically similar samples over dissimilar samples in the latent space. For heterogeneous graphs, we can construct semantic views according to metapaths. Then we propose a multi-view contrastive aggregation objective for model training, where mode embeddings in a semantic view and in the aggregated view constitute positive pairs, and all other embedding pairs are naturally negative pairs. However, the previous scheme presumes that all negative samples make equal contribution to contrastive learning. In this work, we propose to mine hard-cognitive samples for more effective contrastive learning. Considering the smoothing nature of graph neural networks, neighboring nodes will be aggregated, leading to indiscriminative embeddings, which motivates us to discover structurally hard-cognitive samples. In particular, we first compute structure embeddings using three widely used metrics, such as personal PageRank and Laplacian position embeddings. Then we upweight these structurally hard negatives by interpolating to synthesize more negative samples. In this way, hard negative samples sharing similar structural characteristics will be further pushed away. We conduct extensive experiments on 3 real-world datasets and evaluate our methods in both node classification and clustering. It is seen that our method achieves consistent improvements over existing state-of-the-arts. In this work, we present a novel heterogeneous graph contrastive learning framework along with a novel hard-cognitive mining scheme to improve the embedding quality. Extensive experience on 3 real-world datasets demonstrate its effectiveness. Thank you for your listening.